All right, so you guys have been following along with all this crazy stuff about this light-powered car.
Yeah.
1,600 miles on a single charge
Wild.
using light. I mean, is this science fiction or could this
Yeah.
actually happen?
Well, it sounds a little like science fiction.
Yeah.
But the really cool thing is we actually already have most of the pieces
Oh, wow. Okay.
to make this thing work. We've got, these are really high efficiency lasers, advanced mirrors. We've got ways to recycle waste heat back into energy.
So you're telling me, like, we're not talking warp drives and time travel. We're talking, like, actual existing technology put together in a new way.
Yeah, it's like taking these futuristic pieces and putting them together into something.
Okay, I like that. All right, so how does it work? Help me understand. How does a car run on light?
Okay. So imagine you have a battery, sort of like an electric car, and it's powering a system of these super efficient laser diodes. And these lasers are focused into this specially designed chamber. And this is
where the magic happens.
where it gets really interesting.
Yeah, okay. Tell me more.
So they're using the light and they're manipulating it to create spinning vortex, like a tornado of light energy.
Whoa. Hold on.
It's contained within this chamber.
That's a wild visual.
Yeah.
But how does a tornado of light actually move the car?
So this vortex is going to interact with a medium. It could be something like helium gas, and that interaction is actually going to generate thrust. So it's basically pushing the car forward.
Hold on. Let me back up here for a second. How can light actually move a car? I mean, I get, like,
right,
the physics of it, but it doesn't seem like it would be strong enough.
Yeah, so it's all about how you focus and convert that light energy. And so they're using this, very precise engineering to make it happen.
So we've got the light-powered system, but you mentioned it's a hybrid. So why does it need an electric motor? Why isn't the light enough?
Well, think of the electric motor as kind of like a backup and a boost.
Oh,
Like if you need to go uphill or if you just need that extra burst of speed, that's where the electric motor is going to come in.
So it's almost like a fail-safe.
Right. Yeah, you can think of it that way.
Right.
It's about having the best of both worlds. You get the efficiency from the light, and then you get the power when you need it from the motor.
That makes sense. Now, wouldn't a system like this be super, super complicated and expensive to build?
Well, that's what's exciting about this. A small-scale prototype, you could potentially build for maybe about $50,000 to $100,000.
Wow.
And the real kicker is you could probably test it within a year or two.
So this is not like some far-off thing. We're talking like near future.
No, not at all.
We could be seeing this.
Exactly. Yeah, and I think the impact of that could be really huge. So they're working on this prototype.
Yeah.
Picture this kind of lightweight, almost futuristic-looking car cruising along at about 5 miles per hour.
Okay, so we're not breaking any land speed records. But
But you're telling me I can go 1,600 miles with that. I don't care how fast I'm going.
It's really all about maximizing the efficiency, particularly on flat surfaces. Think about your daily commute.
Oh, I see.
Think about driving around a city. You're not going to be setting any speed records.
Right.
But you could potentially go for weeks without needing to recharge.
So you're telling me this little car can drive further on a single charge than most electric cars can even dream of?
For sure. So like a standard electric car, if it was using just the motor at that same speed, would only get about 166 miles on a 50 kilowatt hour battery.
So we're talking like a factor of 10.
Yeah, it's potentially 10 times that distance.
Okay, so you said hybrid, so it's got the electric motor and the light. What if it uses both?
Yeah, even with a 50-50 split between light and motor power, you'd still get an impressive range of 303 miles. So that's almost double what you'd get from the electric motor alone. So even when it's not relying solely on light, it's still way, way more efficient than what we have now.
Yeah. I'm
starting to see why people are really excited about this.
The potential here is massive. And I think it's not even just about cars. Imagine this technology scaled up to things like trains, boats, even potentially spacecraft.
Hold on, Ned. Let's not get too carried away here. You mentioned flat surfaces.
Right.
What if I decide to take this thing, off-roading, up a mountain?
Well, that's where the hybrid part comes in.
Yeah.
So the electric motor is there to provide that extra boost when it's needed.
Okay.
So it gives you that flexibility and makes it a bit more adaptable to all sorts of different driving conditions.
I see. So even if it's not using light, it can still get you where you need them.
Yeah.
Okay. So I'm guessing there are still some pretty big hurdles to overcome before we see light-powered cars actually
for sure.
on the road.
Yeah. I mean, scaling this technology up, I mean, there are some serious engineering challenges. We need to be able to manage the heat. We need to make it even more energy efficient. And of course, it has to be totally safe.
Safety first.
Exactly.
Okay, so let's come back down to Earth. And talk about this prototype car. You said it could be built and tested relatively soon.
What would that look like?
So imagine a compact car, less than 300 kilograms, with about a 200 or 300 watt laser system. Small, 5 to 10 kilowatt hour battery.
Oh, okay.
That's your prototype.
Okay.
That's what we're going to be testing.
No, it's not going to be like some tricked out Tesla or anything. It's going to be more of like a...
bare bones.
Bare bones, yeah, exactly. So this isn't some distant thing.
Yeah.
This is really...
This is happening.
Yeah.
Okay.
And the implications of that...
I'm excited.
Are huge.
Yeah.
Imagine.
Virtually limitless range for electric vehicles. I mean, that's...
It changes everything. That changes everything.
Yeah.
What excites you most about this?
I mean, for me, it's the sustainable transportation angle.
Yeah.
Like, imagine driving across country and never having to worry about, oh, is there going to be a charging station? I'm going to run out.
Totally.
It's like, that's a game changer.
Absolutely.
Okay, so we've barely scratched the surface here, but I think it's safe to say that this is not just some, like, crazy science fiction dream. This is actually being worked on.
Absolutely.
This could really happen. Now, I know a lot of you out there are wondering, how does this work on, like, a deeper level?
Right. We need to get down to the nuts and bolts of this light vortex.
Right, exactly. So we're going to talk about how it's created, how it interacts with matter, and what makes it so efficient.
So we've been talking about this light vortex, but how do you even make that thing? That sounds super complicated.
Well, it is complicated, but let's break it down.
Okay.
It starts with those powerful laser diodes. They emit these focused beams of light, and then they're directed into this special chamber.
And this chamber, this is where the magic really happens, right?
Exactly. So we're talking more than just a few mirrors? What kind of manipulation are we talking here?
These mirrors are not like your bathroom mirror.
Right.
They're very precise, and they're designed to bounce the light back and forth to create this spinning vortex.
So they're basically like herding the light into this tornado.
That's a great way to put it,
Yeah.
And so that precise control, that is what's going to create a really stable and efficient vortex.
Right.
And that's what's ultimately going to generate the thrust to move the vehicle.
I always get lost here. How does swirling light actually create enough force to move something? I can shine a flashlight at the wall.
Right.
The wall's not moving.
So think of it this way. When light hits a surface, it does exert a tiny amount of pressure. It's usually way too small to notice.
Yeah, of course.
But in this system, what they're doing is they're amplifying that pressure. So by concentrating and spinning the light,
I see.
You create a much stronger force.
So it's like taking something that's very weak and multiplying it exponentially.
Exactly.
That's pretty cool.
It is. And they're even taking it a step further and using something called quantum reflectors.
Okay, hold on. Quantum reflectors.
Yeah.
Now you're just making stuff up.
No. So these are these special materials that are going to manipulate the light at a quantum level, which can potentially make this process even more efficient.
So they're like what? Like super-powered mirrors?
You got it, yeah.
Yeah.
So using quantum mechanics to really fine-tune this light vortex and make it even more powerful and efficient.
I have to admit, the quantum stuff always makes me kind of cross-eyed, but I think I'm getting the idea. So we got these powerful lasers, a carefully designed chamber, and then these quantum reflectors all working together.
Yeah, exactly.
This is wild. And it's actually,
being tested. Like this is happening NOW.
Yeah, and this is what I think is so exciting about it. It's not something that's decades away.
Right.
You know, and remember, we've been talking a lot about cars, but think about all the other applications.
You mentioned trains, boats, and even spacecraft.
Yeah. Right.
But realistically, are we talking like, as soon as the car or?
So I think the car is the most feasible near-term application.
Okay.
But there are some really exciting research happening in other areas. Like there's people experimenting with this type of propulsion system for small satellites.
Oh, wow. So light-powered spacecraft are not out of the
not completely
realm of possibility. Okay, so we'll get there. But let's bring it back to the car for now.
Oh, Mike, sure.
There are people out there that are, a little skeptical.
Yeah.
What are some of the biggest concerns about this technology?
So one of the things I hear a lot is about cost.
Oh, of course. Yeah. Like, is this ever going to be affordable for the average person?
Right.
It's a valid question. I mean, right now it's very expensive to build these prototypes. But, like any new technology, the cost is going to come down as production scales up.
Of course, yeah.
And we start seeing some more innovation.
So it's like the early days of computers, or smartphones.
Exactly.
Yeah, okay. That makes sense. Safety's got to be another one, right?
Huge, yeah.
I mean, people hear powerful lasers, they're picturing like, accidental zapping.
So safety is absolutely a top priority, and they've really thought about this.
Okay.
They've designed these systems with multiple layers of safety, fail-safes.
Okay.
It's not like there's just a laser beam shooting out the front of the car.
Right.
This light is all contained within the chamber.
I see.
And the entire system is rigorously tested to make sure that it's completely safe for operation.
So no accidental laser shows on the highway, all right? That's good.
Exactly, yeah.
But even if we can get the safety part down, there's still the question of practicality. I mean, this thing designed for these perfect flat surfaces.
Yeah.
What happens when it hits the real world with all the,
That's what they're testing in these prototypes, is to see how the system performs in these real-world conditions. And remember, it's a hybrid, right?
Right.
So you've got that electric motor to provide that extra power.
So if I want to climb a mountain, you can
climb that mountain.
Switch over to the electric, and I can climb the mountain.
Exactly.
Okay, I like that. So we're talking about efficiency.
Right.
But where does that energy come from?
Right. So the current prototype is using a battery to power the lasers, just like an electric car. But the long-term vision is to actually make this even more sustainable by integrating renewable energy sources. Think solar panels.
So hold on, let me get this straight. We're talking about a car that uses sunlight to charge itself and then uses that same sunlight.
It's like the
ultimate goal.
It's amazing.
Even if the car isn't directly powered by solar, the light-based propulsion system still has huge environmental benefits. It's so much more efficient than a combustion engine.
Okay, so it sounds like this is a major step towards
potentially, a
cleaner future.
It has the potential to be that. But it's still very early days, right?
Right.
There are a lot of challenges, still a lot of research and development to be done.
Yeah, this is definitely a journey worth taking. I mean, it's all about pushing the boundaries of what's possible. Speaking of which, let's change gears a little bit here.
Okay.
I want to talk about the WHY. Like, what are the implications of a car that can go 1,600 miles on a single charge?
Well, think about it. Range anxiety is
gone. Exactly. It's a thing of the past.
No more hunting for a charging station on a road trip. You can
go anywhere you want.
And it's not just, personal convenience here. Right? Think about shipping, logistics.
Well, absolutely. Yeah. I mean, trucks and delivery vehicles, they could cover these huge distances without refueling. It would revolutionize supply chains.
It could literally change how we move things around the world.
Absolutely. Yeah. It raises a lot of interesting questions, too, though.
Oh, yeah, of course.
How would our infrastructure need to adapt?
Right.
How would this affect the energy sector?
These are big questions.
They're big questions. And how would it change our lives? Right?
Exactly. It would change everything. Okay, so we've talked about the range and everything, but what would it be like to drive? Like, what would it actually feel like to drive this thing?
So we don't know everything yet.
Of course. Yeah.
But we can make some educated guesses.
So we're talking about a car that runs basically silently, powered by a beam of light.
Pretty much, yeah.
That sounds like something out of a movie.
Right.
What would it actually be like to drive this thing?
Well, I think based on the design, it would be a super smooth and quiet ride.
Okay.
I mean, there's no engine roaring, no exhaust fumes.
So you're just gliding along.
Yeah, you're just gliding along, propelled by this invisible force.
I like that. Would it feel powerful?
It might not have that aggressive acceleration like a sports car, but remember, this technology, it's all about efficiency and sustainability, not, breaking speed records.
Okay, so more like, smooth, effortless kind of cruising experience. But that does bring up a question. If it's so quiet, wouldn't that be dangerous for pedestrians?
Right. So that's something that engineers are already thinking about. And they're exploring ways to add in artificial sounds to the vehicle.
Almost like electric cars do.
Kind of like electric cars, yeah.
To kind of let people know.
Exactly. To alert pedestrians. So they're more aware.
Okay, that makes sense. So let's zoom out a little bit here and talk about the energy industry as a whole.
Oh, yeah. So This technology,
This could be a big disruption.
it could be huge. If we start seeing widespread adoption,
Yeah.
it could drastically reduce our reliance on fossil fuels.
Okay.
And that would have a ripple effect
Of course, yeah.
throughout the entire energy sector.
We could potentially see a shift away from oil and gas
It's possible, yeah.
towards these renewable sources.
Right.
That's a huge change.
It's massive.
Yeah.
And, it's not just about reducing emissions and combating climate change. It's also about energy independence.
Oh.
Countries that rely heavily on oil imports
Okay, yeah.
could become much more self-sufficient.
So this is it's a global...
It could be a global game changer.
Game changer. Yeah. We can't forget about the economics of this whole thing either.
Yeah, absolutely.
This kind of innovation would create all kinds of new industries.
Yeah, huge growth in fields
Jobs.
like laser technology, material science, advanced manufacturing.
Yeah, this could be a real boom. But with any kind of big change like this,
Right.
there's always potential downsides. What are some of the challenges?
Well, one of the biggest challenges is infrastructure. Think about it.
Right.
Our current infrastructure is built around gas stations and charging stations.
We have to completely change.
We had to adapt.
We do everything.
Yeah. And then there's the question of accessibility.
Right.
Will this be affordable
Yeah.
for everybody? Or is it going to be something that only the wealthy can afford?
Yeah. That's a big question.
Yeah, at the beginning.
Yeah, it's got to benefit everybody, right?
Absolutely.
So this has been absolutely fascinating. It sounds like this could really revolutionize.
It's pretty amazing.
A world.
It's wild to think that something that seems impossible might actually be within our reach.
Right.
Well,
it's a testament to human ingenuity, for sure. It makes me really optimistic about the future.
Me too.
If we can figure out how to power a car with light,
absolutely,
what LSE can we do?
I think the possibilities are endless. It all starts with that curiosity and imagination and just that willingness to explore the unknown.
Well said. Well, we have reached the end of our deep dive into the world of light-powered cars.
It's been fun.
I hope this has been informative. It's definitely gotten me excited about the possibilities, and I hope it's done the same for you.
Me too.
Keep asking questions. Keep learning. Keep diving deep into all the amazing things that are out there.
Absolutely.
Until next time, keep those imaginations running wild.